Now, I know that I want to find out what the monthly payments are. I need to calculate the monthly payments, which means that this is my unknown. That's my question mark, which means I need to puzzle out what is the final value. I've been able to eliminate all the other variables, dealing with them one at a time. This is how you truncate or chunk up a problem to try and problem solve it out. What would the final value be? Okay, let's think about the context. The final value. What would be the final value after 5 years? If I'm being left money in a will, the will is going to be paid out to me over the course of 5 years, which means at the end of the 5 years, how much money would I have left? Well, if the will stops paying me after 5 years, this is what we're hoping, like this is what we are building into this, right? Well, then the final value in the will is 0. So sometimes we have 0 as a final value, even with annuities. And that's because we have to think about the context of the problem. And we had to kind of just ignore all the other variables, which I was able to do once I figured out what those variables were. And then just think about, what does this mean in the context of the problem? Now that I have all of those, it's pretty straightforward to just plug them into my calculator. 60 here, 8. If you didn't know that that's 60, if you just do 5 times 12 and then scroll down, it does the calculation for you. So you don't have to do that calculation outside. The present value is negative 5,000. The payments are my unknown, so I'll delete that and move on. The final value will be 0. Payments per year is 12. And if I scroll down, it goes to 11, which is super frustrating. Scroll to the right a bunch, and then I can scroll down, and that's automatically changed to 12, which is nice. I'm not going to scroll up because of that annoying piece of the calculator. So I just click on payment and press enter. I get 101.38 euro. So I do know that I can do 2 decimal places, 101.38. It's positive, which means it's going into my pocket, out of the bank and into my pocket. So the monthly payment to me, or to Julia, is 101 euro and 38 cents over 5 years out of this will. There we go. So that's how we deal with annuities. That's how we know what is an annuity. A lot of times it'll say annuity, but if it doesn't say annuity, we know that it will be an annuity because we are dealing with this idea of saving money, not paying off money, and because we have payments. So then an amortization is still this idea of payments, but instead of a payment of saving money, this is a payment of paying off money. This is for loans, like a mortgage or student loans, borrowed money. Sorry, that was my phone. Still payments, and still dealing with the payments, that like the PMT and the PPY in the end, still the same stuff. And now we're just dealing with it as this idea of paying back money that is owed. Okay. Clotilde takes out a loan of 35,000 for a car loan. So that's how I know that it's amortization. The loan is for 10 years at 1% interest for find out how much has to be paid each month. That's a lot of information. It's actually got all the information at once. So I'm going to think in my brain, okay, I'm in the category of amortization. Amortization, I have to use my finance solver. Okay, finance solver means I have this list of variables that I need to answer. So N, I, P, B, PMT, FV, PPY, CPY. And remember, writing these out gives you your so I encourage you to write them out. Even though, yeah, I'll do this with you. I won't ask you to do it on your own. Take it one step at a time. Clotilde takes out a loan of 35,000 for a car. So that's how much we start with. We have borrowed 35,000. Now that 35,000 comes out of the bank and into our pocket. So that present value that we're starting with, 35,000, is positive because it's being put into our pocket. The loan is for 10 years, but times how many months? 1% interest per month. I think that's one. I'm going to double check. I'm changing how I teach this, so just a little bit of a context there. I think that's one. It might be 1 times 12 to be interest per year. Let's look at how they've titled it on the thing. It just says interest rate. So I think 1 is fine if we just leave it like that. But the fact that it says interest per month makes me think, do I need to do interest times 12? I'm going to double check that. And how I'll double check that is I know what the answer is, and I'll just play around with it and we'll see. Okay, I think it's 1. Find out how much she has to pay each month. Okay, so payments we don't know. Okay, so each month payments per year, that's 12, which means it compounds back 12 times per year. It reconvenes back into the pocket of money, and so it's compounding back together each time we make that payment. Final value. Pause and think. We start off with a bunch of money. We want to, at the end of these 10 years, we want to pay all of the money back. We want to have no more money left that we owe. So that's going to be 0 as our final value. And I set up the system here, reminding myself, hey, future Megan, watch out. It's not just 10, it's 10 times however many times I make a payment per year, which is 12. So that's going to be 120. Okay. So I put these values in, and I can do 10 times 12, and it does the calculation for me. Awesome. I'll put 1 here, and we'll see what happens. 35, 1, 2, 3. For the zeros. Payment is what I'm trying to solve for. Final value is 0, and the rest of these guys are 12. I had already made them 12 before, which is great. So I just scroll on this guy and press enter. And that is the wrong value. So, okay, I think what I do need to do is 1 times 12. And then, nope, 1 times 12. And then if I recalculate the payment and press enter, that is the correct value. Okay, so because it says interest per month, this is supposed to be interest per year. So 1% per month, which means for each month, that's 12%. So you just need to make sure that you multiply that by 12. So that's a tricky thing that I had some alarm bells going off in my head, and I was like, I don't know what I need to do there, and that's what I needed to do. So the answer is supposed to be negative 502.15. So PMT equals negative 502.15. Negative because I'm paying back this loan that's coming out of my pocket. It's going back to the bank. So my monthly payment, or Clotilde's monthly payment, is 502.15. Now, we have a couple of questions that build off of this, right? These are not IB level questions. These are just getting you used to using the finance solver. And so what if I were to ask you then the total amount that Clotilde pays back? So you haven't been asked this, but what if I asked, what is the total amount Clotilde pays back? Well, we know how much Clotilde pays per month, and we know that she pays that 12 times per year, and she did that for 10 years. So if I want to know how much she pays back over the course of the entire loan, you might think it's $35,000. Except for, why would a bank loan you money if they're not going to be making money off of loaning you money? You are not paying back $35,000. You are paying back more than $35,000. Let's see how much more you pay back than $35,000. So we take that monthly payment and multiply it by the months. And then the number of years that we do this for. I'm going to go back to my calculator. I'm going to press literally Control C, then go to my scratch pad by pressing escape. And if I press Control V, I have just brought that value here. I'm going to multiply it by 12 and multiply it by 10. It's negative, but we know we're actually just taking that positive value. And the answer I get is 60,257.80. 798 means that 9 rounds up and the 8 rounds up, so it becomes 80. Okay. Clotilde borrowed 35,000. At the end of 10 years, if this is her monthly payment, she pays back over 60,000 euros. That's just shy of double the amount that she originally borrowed. That's a lot more money. This is how banks make this is one of the many ways that banks make their money. If they say, fine, sure, yeah, we can let you borrow this money if you would like, it's because of the interest. This 1% interest per month that they are charging you for borrowing that money means you're paying more money than you borrowed, right? So if we originally got 35,000 to pay for something, maybe it was school, maybe it was a house, maybe it was a car. If we borrowed 35,000 and we paid more than 35,000, how much interest did Clotilde pay? In other words, how much more than what she borrowed did she pay? So we take the total amount and we would subtract the amount borrowed. And that difference, that leftover amount, is how much more money she borrowed or paid. I'm going to multiply it by -1 so it can become positive and then subtract 35,000. 25,257.80. She paid over 25,000 in interest. I'll be exact. With an interest rate of 1%, she paid that much in interest. So these are classic questions that we follow up in an IB problem that says, okay, you just use your finance solver to solve for monthly payments, but now you can figure out how much she paid back in total over the 10 years. And now you can figure out, well, how much more did she pay than what she borrowed? In other words, how much interest did she pay? Right? So just trying to think about these follow-up questions. They're pretty straightforward. The calculations are not any new calculations. You know how to multiply, you know how to subtract, right? But this wouldn't be something necessarily that we would cover. You have to be able to think about it in the context to be able to answer these questions. So there's lots of other questions that could happen here. Just make sure that you understand what these words mean as we're going through and practicing these together in class. Okay, awesome job. I'll see you next time.